All right, so it is good to see everybody. The plan today is we'll go ahead and talk about any questions you might have on the quiz from yesterday. We'll go ahead and look ahead to 1.6. That's going to be polynomial functions and in behavior. So depending on how many questions we got, we may actually have some time in class today. But tomorrow, we'll go ahead and definitely finish up 1.6. I would like to go ahead and start looking at the homework for 1.5, even though it is officially due on Friday. And then after the long weekend, we have a 1.5 quiz on Tuesday. Okay, so questions about anything coming up? Bless you. And what happens today during 8th period? Okay, lockdown. In fact, you notice I've already got the blinds down, so just getting prepared. They said about 3:45-ish in the email, so just give you a heads up. Okay, so let's take a look. Your class average, 95.1, so fantastic. Okay, what questions did we have? Great. Let's take a look. I believe that's the polynomial one. All right, so f of x equals 1.31 x cubed minus 1.57 x squared minus 4.62 x minus 1.98, where the domain is between negative and positive 3. So we're looking to find a relative maximum and relative minimum for the polynomial. Okay, so this one is strictly a calculator problem. So let me come on over here. We'll go ahead and plug this in. All right, let's see here. Okay, so it is a 1.31 x cubed. So I'm going to use this caret button here to raise it to the third power. Minus 1.57 x squared. What do we got? Minus 4.62x, and then a minus 1.98. Okay. All right, so we got my graph here. We go ahead and kind of move this out of the way. So we can see that there's a relative maximum here. The relative minimum is just off screen. So why don't I do this? Let me go into the window here. Let me go ahead and change the domain to what they gave me in the problem. And then for the y minimum, let's say negative 10. Okay, so we should be able to see that. There we go. All right, so I'm just looking for these two locations right here. What were the keystrokes to do that? If I'd say this one. Okay, menu. We're going to analyze, and we're looking for the maximum. Okay, so it's going to give you that vertical line. So if I'm looking for this location here, lower bound, put that line to the left of what you want. Push enter, it locks it in place. Upper bound, we'll just sweep it across. Okay, so I have a relative maximum that occurs at a negative 0.756. Okay. And then do it again, menu, analyze graph, but this time I'm looking for the minimum. So I want this one here. So lower bound is left. Upper bound is right. And what I did on the quiz yesterday, I did go ahead and say round to the nearest thousandth, so 3 decimal places. But if anybody gave me 2, I still went ahead and accepted it because I was seeing that some calculators were doing that. But I do want to give you a heads up when it comes to the AP exam, the free response questions. If they don't tell you how to round, what number of places is always good? 3. Okay, so they are going to want you to round to the nearest thousandth, 3 places, if they don't tell you specifically in the problem. Okay, and who asked about number 8? Okay, William, is that good? Okay. All right, what else? Yes. Let's talk about 7. Okay, so 7 says the graph of the function k, which is not shown, is concave up. Okay, so concave up, remember we've got the cup. So I'm going to go ahead and draw something that's concave up right there. Which of the following table of values could represent k? All right, so what I was thinking here, what defines concavity? What do we actually track the progression of? Starts with S. Talking about slope, we want to know how slope changes. Now, because we've got a curve here, the slope is constantly changing, which is why we were looking at tangent lines. So let's say if I start here, makes contact, so we're going from a negative, okay, to 0 to a positive. So if we have concave up, then the rate of change, the slope is going to be increasing. So what I need to do is go ahead and find the slope for these tables, and I'm looking for the slope where it's getting larger. Now, you'll notice all of these tables, they all have x values of 1, 2, 3, 4. They're all equal with equal length intervals. There we go. Can't get that out. So, for example, let's say I believe that A is the right answer. Now, because we're looking at these consecutive intervals, when I would subtract the x's, well, that would just be 1 every time. What happens when you divide by 1? Nothing. It doesn't change the value, right? So that's why we can kind of ignore that. So we'll just focus on the y values. So 4 minus 1 is going to give me 3. 7 minus 4 is 3. 10 minus 7 is 3. Well, the slope isn't increasing or decreasing. It's just constant. So I know that can't be the set of data. Okay. If I were to go ahead and try B, same thing. Well, let's see. 6 minus 1, that's going to give me 5. 9 minus 6 will give me 4. 11 minus 9 will give me, 2. Oh, yeah, I just realized it. Yep. I'm a math teacher. Okay, there we go. So 5, 3, 2, so we do have different slopes, but it's what? It's decreasing. The slope is getting smaller. Okay, so that was kind of the way that I went into that problem. And it turns out which one is the answer, C or D? D is the answer. Okay. So if I take a look at this, negative 3 minus 1, that's negative 4. Negative 5 plus 3, that's a negative 2. And negative 6 plus 5, remember when we subtract a negative, it goes positive. So that's a negative 1. So negative 1 is the largest of the ones we have there. So the slope is getting bigger. Okay. It is increasing, so that would have concave up. Right. Next. Anything else we want to take a look at? Okay. Well, if anybody's interested in retaking this, you have until next week to go ahead and do so, because it's a short week. I'm going to give till Friday morning of next week, so you have plenty of time. You just have to make sure that the assignment is completed before that. Okay, so let's go ahead and put this to the side, and let's go ahead and pull out 1.6. Right. So we're going to talk about what we refer to as end behavior. Okay, 1.6, end behavior. All right, so it says the end behavior of a function describes how a function behaves as it moves infinitely to the right or the left. So when we're looking at a graph, some kind of grid, we want to be looking at the right side and the left side. Okay, now mathematically, the end behavior is what happens to the values of f of x as x increases or decreases without bound. Okay, let me go ahead. So when you see that phrase, for example, x is increasing without bound, this is what we're saying in notation. X, we have an arrow. Now that arrow means approaches. So x is approaching positive infinity. Okay. X is increasing without bound. It's just going to continually get larger and larger forever. Or if x decreases without bound, well, that means that x is going to approach negative infinity. Now, what we're going to be doing today is taking a look. We're going to be verbally and using notation describing the behavior. So in this box here, as the x values decrease without bound, as x goes to negative infinity, the y values of f, and then you would just describe what you see happening on that side of the graph. Same thing over here for the right end behavior, but let's take a look at the notation. Okay, this LIM right here, what do you think that stands for? That's the limit. Okay, so we're going to take the limit as x approaches negative infinity of f of x. That's how we say the notation. So if x is approaching negative infinity, we're going to be looking at the left side of the graph. Okay, but the thing about the notation here, you have to have all three of those parts. You've got to have lim, the limit, x with the arrow approaching whatever, and then you have to have the function immediately following that. And then you would go ahead and put equals whatever it is you see. Okay, and then for the other one here, the limit as x approaches positive infinity, that's the right side, of f of x, and then it equals, again, whatever you see. Now, eventually, we're going to go ahead and work up to horizontal asymptotes. So we're going to be approaching a specific value, but for right now, we're only interested, is the left and right side, are they curving up towards positive infinity, or is it curving down towards negative infinity? That's all we want to do in this lesson. Okay, so with that in mind, let's look at example 1. Describe the end behavior of the following polynomials verbally and using limit notation. Okay, so I got this polynomial here. So here's my sentence that we're going to go ahead and fill in the blank. And where it says W/O, that just is abbreviation for without. So as the x values decrease without bound, remember, as x approaches negative infinity, okay, so we're talking about, here's the left side, as x approaches negative infinity, and then here's the right side, x would approach positive infinity. The y values of f of x blank without bound. Well, look at the left side of your graph. Okay, is this polynomial curving up to positive infinity, or is it curving down to negative infinity? What's happening on the left side? Yeah, it's curving up, right? So what are the y values going to be doing? Will they increase or decrease? Yeah, as the x values decrease, as we go significantly smaller, those y values are going to continually increase without bound. They'll get infinitely large. Now, that's how you state it. Let's go ahead and write the limit notation. Remember, you got to have those three parts. So I'm going to go ahead and say the limit as x approaches negative infinity of f of x. Now, because the left side of the graph curves upward, I'm going to say this equals infinity. The output values are going to get really large really quick. And now we're going to do the same thing for the other side, though. As the x values increase without bound, the y values of f, okay, so I'm looking at the right side, does it curve up like the left does, or does it curve down? Okay, it curves down. So Harrison, what do you think I'm going to put in this blank right here? What are the y values going to do? They're going to decrease without bound. Yes. They're going to decrease without bound. So now I'm going to write that notation. So the limit as x approaches positive infinity of f of x. So because it's curving down on the right side, I'm going to say this equals negative infinity. Okay. This notation is describing that the y values are going to get increasingly small forever. Okay. And that's it. That's basically the core idea of this lesson right here. Questions. Super easy, right? Okay. Well, let's go ahead and try another one. Okay, B. Got myself another polynomial here. We want to do the exact same thing. So we're going to state on the left side, okay, so again, here's the left, here's the right. As the x values decrease without bound, as x approaches negative infinity, the y values of f blank. Bailing, based on what you see here, are you going to say they increase or decrease without bound? I'm sorry? Decrease? Is that what you said? I'm sorry, I'm old. You're close. Increase. There we go. Because on the left side, is it curving up or is it curving down? It's curving up, so that's going to increase. Okay. So now what I want you to do is take a few seconds, write me the limit notation. Okay. Write that out for me. And let's see, we're out of here at 20. Okay. We are definitely going to have some time in class today. All right, so here's what we should be writing for the left end behavior. The limit as x approaches negative infinity of f of x. Remember, you always, always, always need those three parts. And because we said the left side is going to increase, we're going to set that equal to positive infinity. Remember, that's all we're talking about within behavior. The far left and the far right, is the graph curving up towards positive infinity, or is it curving down towards negative? Okay. Akil, help me finish this statement. As the x values increase without bound, as x approaches positive infinity, the y values of f, what? They increase. On the right side, it's curving up as well. So we're going to increase without bound. Okay. And who can tell me what to write for my limit statement? Ryan, help me out. And then we limit on top. So the limit as x approaches infinity of f of x equals positive infinity. There we go. Okay, so is there anybody who's not seeing why we're writing it in this particular way or what we're doing? Okay. Cool, cool, cool. All right, well, we've only got a couple of problems left, and then we are done. It'll be a pretty easy day. Example 2, sketch a polynomial function with the following end behaviors. Okay, so A, it says we have the limit as x approaches negative infinity. Remember, that's the left side. So I want it to be negative infinity. And the limit as x approaches positive infinity, remember, that's the right side of your graph. Okay. Well, how many different graphs do you think would satisfy these two conditions? A lot. Okay. So you just flip B? Oh, from the previous one. Okay. Unfortunately, Ayla, I'm not quite understanding what you're meaning. Could you come show me? Yay! Hey, that's okay. My handwriting isn't pretty. Okay, there you go. So the left end behavior, it says negative infinity. So yeah, it's got to curve down on the left. The right end behavior is also negative infinity, so it has to curve down on the right. She went ahead and gave us a couple of relative maximums, a relative minimum, and even a couple of points of inflection. So remember, any type of graph, as long as it satisfies these conditions, what about just a good old parabola? Even just a quadratic reflected down? No, 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 I'm just showing you different examples. Hers was perfect. It was perfect. Okay. All right. So let's try B. So let's see. The limit as x approaches negative infinity of f of x. Okay, so the left end behavior, we want it to go to negative infinity. And the limit as x approaches infinity g of x, the right end behavior, we want it to go to positive infinity. Okay, so who thinks they can come on up and show me a graph that will meet both of those? Mira? Okay. Oh, Naya, did you want to do it too? Sure. Teamwork makes the dream work. Okay. Okay. There we go. So I see what you mean. I see what you mean. Okay. So basically, you're describing a cubit. Yeah. Okay. There we go. Okay. No, no, no. That's fine. I know that seems kind of sketchy. Sketchy. Because it's a graph. Yeah. There you go. Okay. Yep. There you go. So as long as your graph, okay, is curving down to negative infinity on the left, and it would be curving up to positive infinity on the right. Again, there could be an infinite number of graphs to put in there. Okay. How are we doing? Easy, right? Nice. Okay. Then all I need you to do is go ahead and copy this down. This is as far as the other classes got. Well, third period, remember third period I was trying to catch them up since last week because remember we had the late start day on Thursday and I didn't see third period. So every day I've been trying to catch them up. I finally finished up 1.5 with them and then we did 1.6 with the quiz. So that's why there's some time in class today. But once you go ahead and copy all that down, we're done. We should keep going. What?
We should keep going.
Well, every day is a free day, right? Because I never charge you to learn. It's a real knee slapper. And there's not a lot left on this, so we should definitely be able to wrap this up tomorrow and go ahead and start talking about the assignment as well. That's my goal. So we've got about 23, 24 minutes left, so I know, right? Okay. Unfortunately, my ping pong stuff is